So what we're going to do is we're going to define each of these, and then I'm going to have you discuss as a group where you think these characteristics would belong on the function's graph. So here's a rational function. At the beginning of the year we said that it sometimes looks like a sideways butterfly. Not all the time, but most of the time, because you can also have some that look like these. They get kind of crazy, but for right now we're not focused on graphing them. We're just going to look for these important characteristics that are involved. So let's start with domain and range. Group 2, what's the definition of domain? It's not somewhere, just think of it. Okay, all possible x values.
Are you recording?
Maybe.
Oh man, I'm gonna hear myself in that.
Hello, world.
Okay, but for rationals, we're going to stick to interval notation, which before you guys went to lunch, we said involved what symbols?
Brackets, parentheses.
Brackets, parentheses, with commas in between, right? Okay, well, you're also going to see something with rationals, because with rationals, we have a lot of discontinuities, things that break up your graph. So if we're breaking up domain and range, you're going to have separated pieces. And we use what's called a union. It looks like a U, and it's called union. The English word for union is or. And the question people ask is, why don't we just say or? Well, you can, but math has its own language. And the language is union. And we can say or when we're saying English things for math proofs. But we're not doing that. Just know that when you see the letter U, it means union. Okay, so really quick, just to make sure you understand, if I were to tell you, here's your domain, what does that mean?
-2 or 3.
Well, there is no union in here.
-2.
Yeah, those are the numbers. What does that mean?
That's where it starts.
Starts at? Starts at?
-2.
Ends at?
3.
3, okay? But one has a bracket, one has a parenthesis. So it can't mean I start at -2 and I end at 3. There has to be some other details in there.
Like,
Start at 2 and then in the vicinity.
What do you mean by can't even say that word. Yes, what do you mean by that?
Like,
You're not wrong.
parentheses means in an area. A bracket means that point.
Exactly. So a bracket means you can equal. It's a definite stopping point. You're going to equal -2. Think of it as a closed circle. Like I'm going to -2. Here's -2. I stop there. It's a definite point. 3 means, well, I'm going in that general direction. I'm doing what? I'm approaching 3. But at 3 is going to be what's called a open circle. Meaning you get really close to it, but does the value 3 right here actually exist? No, you just approach that number. You're hugging it. You get super, super close. So that's the difference between brackets and parentheses. Brackets means you equal. Parentheses means you approach. And when we get to writing the domain and range later, we'll talk about when this union comes into play. Okay, range is almost the same. Group 1, what does range mean? All possible y values. And we'll use the same notation. We don't have to write it again. Okay, so now what I'm going to do is I'm going to write the actual formal definition of asymptotes and the removable discontinuity. And I want the people in your group to discuss where you think that's going to occur on the graph, just based off the definition. All right, so let's start with horizontal asymptote. A horizontal asymptote is obviously horizontal. I shouldn't have to tell you that, right? It's horizontal. But it's an invisible line, not point, line, that the functions so for instance, this is the function right here, and this is its graph. So that the functions and behaviors approach. So horizontal asymptote, invisible line that the functions in behaviors approach. Now, they sometimes can cross it, but not all the time. So I don't want to put that piece in the definition where I say, we'll never cross it. So I'm just going to say the word approach, because in pre-cal they'll get very mad at me whenever you see things that you can cross. Which you can also see in here too. But horizontal asymptotes, just based off of this. Think to yourself, an invisible line. So looking at this graph, it's going to appear as maybe a dotted line or something because it's invisible, it's not really there. That the end behaviors, the ends of the graphs, the direction that they're heading, are approaching. Talk with your group. Where would you draw that at? On here.
Where that line is.
And then I'll go around and I want your group to point to where it's at. Where do you think the horizontal asymptote would lie on this graph based off of the definition? I know, where? There's a specific area. Talk to your group. Everybody in your group should know where it's at. Just point to it to make sure everybody knows where they think it is.
I just know like time saw all of those. I was literally just
Don't give me that look.
this actually map. But when I stay up late
Oh, it's that. Oh, no. I didn't see that. It's right there. It's right there, man.
How do you read a graph? Left to right or up
When
on
you said
top?
spaceship, I thought you meant a rock.
So then where are the end behaviors? Those are the end behaviors. The other ones are not left and right. So those aren't end behaviors. Where's that? Yep. Where's that?
It's the invisible line.
That's a diagonal line that you're drawing from here.
Oh, yeah.
What?
We're going diagonal. Okay, so where's the horizontal line?
So then it's this one.
Yes. Horizontal line. It's not a point. A horizontal line. The whole thing. Let's see. All right. Yes. Okay. So it seems like most of you pointed to it. So what I mean by end behaviors are the ends of the graphs as you're going left to right. The x values in a sense. But as you're going to the left, this line right here, this section of the graph is getting really close to 2 as a y value. Same thing over here. It's getting really close to 2. But if you notice, they're going in opposite directions and they are approaching the same exact number. Is this line that they are approaching a horizontal line?
Yeah.
Oh, then this would be my horizontal asymptote. Okay, my next question is, if this is my horizontal asymptote, which is a line, do we represent lines with equations or with coordinates?
Equation.
an equation. So if I were to tell you, go graph this line, how would you represent to somebody that this is the line we're talking about? What would you say?
0, 2. Wait.
That's a coordinate.
2.
What is 2? Y equals 2. Very good. And that's kind of misleading because some people think it's the x value because it looks the same as the x-axis. It's the same direction. But what value are we cutting through? We're cutting through what number? 2. And 2 is considered a what number? A y value. It's on the y-axis. So it's y equals 2. Any question on that?
No.
All right, let's fill in the next one. Vertical asymptote. So vertical asymptote is kind of the same except it's a discontinuity. It's an invisible line. That the function doesn't equal, meaning it will not cross. So on this one, not only do I want you guys to find it, I want you to think about what the equation would look like. Should be pretty simple. So an invisible line that the function doesn't equal, meaning it will not cross this value. Find it, and then what do you think the equation would look like?
Someone was that.
Find it, and then what would the equation look like?
Miss, why'd you throw away the other one?
X.
I don't know what you're talking about.
That one?
What this?
I don't know.
Yeah, because somebody tried to copy me, but they didn't do very good. Oh.
Yeah. That would come back down. We're really going. We're all confused how to do it now. This weather sucks.
Oh my. Is it x equals 1?
1?
Or x equals 1?
Equals with 1?
Oh, what is it?
Which side are you on?
Negative.
There you go. All right. So yes, it was this vertical line right here. It's separating both sections. This would be the vertical asymptote, which we're going to abbreviate VA. And what would be the equation?
X equals
What
negative-
value is this?
Negative 1.
-1, and is that an X or a Y?
X.
It's an X. So the equation would be X equals -1. So now that we know how these lines work and what their equations would be, let's go over here and put X equals so that way we remember it's always an X value when you talk about your vertical asymptotes. And for horizontal, we'll put Y equals so we know it's talking about your Y values. Okay, the very last characteristic, and then we'll write our domain and range. Okay, removable discontinuity, aka we can call it a hole. So imagine yourself walking on a sidewalk and then you fall into a hole. Can you keep walking on the sidewalk? No, because it breaks up the sidewalk. A really big giant hole where you fall into the crust of the earth.
Who the hell does not see that walk at all?
Okay, exactly. So you disappear, right? Pretty much like you fall into a hole. You are no longer on the sidewalk.
Search team.
So is a hole an entire line? Are we going to graph a line if I'm talking about a hole, you
No,
think?
you draw a circle.
It would be a circle. So think about us removing a circle from a graph. What does that sound like?
A circle.
Think of graphs now in math. What does it sound like when you're removing a circle? What would we be talking about?
Shape things
in math on a graph
Diameter.
an open circle, which is a
Then you keep going. No.
Something in the area.
is it an equation?
No.
What's an open circle?
An equation. What the hell?
And never ending.
It's not an equation.
Definitely.
A what?
A number.
Sully's getting it.
I don't know, a parenthesis.
Uh-huh. What do you call those?
Parentheses.
I'm not gonna say it. Someone's gonna say it.
Zeros.
Y'all are really overthinking this.
Bracket.
I'd go put it on there. There's a circle on the graph.
A dot.
Decimal zero.
Point. Point.
Thank you, Jenna. It's a point. It's a coordinate.
You were really overthinking.
You really were. He was like on the spot. Okay. So your calculator may or may not show this, but if you look really closely at this graph, you see how this looks like a bolded point?
Yeah.
Well, this is actually a hole on this graph. And we're going to draw an open circle around
It
it.
needs to be open.
Exactly. It needs to be, but it's not. Because your calculator doesn't graph those open circles like that. You graph the open circles. You got to be smarter than the tool you use. Okay, so we know that this is going to be an open circle for the time being because I'm providing you the graph. So what do I call this then? Is this something that exists? What did I say? You're walking on a sidewalk. Here we go. We're walking on the sidewalk, and then we fall into a hole. It stops your graph. It's a discontinuity. You have a breaking point from this side to this side because you fell into a hole. We call this a removable discontinuity. It is a point that is being removed from the function. Any question on that?
No.
Okay, so let's go fill that in. A coordinate, which is the same as a point. That is removed from the function. So then would I use an equation to represent this?
No.
You would use a coordinate. Duh. And coordinates have a
Two numbers.
two numbers, a what?
Parentheses. What the heck? What you doing? X and Y.
An x and a y. Very good. So we know that we would have a coordinate. X, comma, y. So let's go fill in what would be our removable discontinuity for this one. What is this coordinate?
-2, -2.
-2, -2. All right, question on the last three characteristics, the ones that we covered. So we have asymptotes and we have a removable discontinuity. Okay, the last thing I want to do, and then I'm going to let you guys practice one of these, is we're going to do the domain and range in interval notation. Now remember, if I have a breaking point, for instance, this hole is a breaking point. Does it exist on the graph? Could I say I can equal -2?
No.
No. Could I say I equal -1?
Yeah. No. No.
No, because will this graph ever cross this vertical asymptote?
No.
So then you can't equal -1. Can I equal 2? Does it look like we're going to cross 2?
Yes. No.
They're going in two opposite directions.
No. They're not touching the.
They're not going to touch. What is this called? They're doing what to this line? What do we say? Approaching it. So is it going to equal it?
No.
No, you cannot equal 2. So y'all see all those areas that we cannot equal, yes?
Yeah.
All right, let's play co-extension. Here we go. Which means you gotta look at the board. Look at the board. No, we're not. We're getting there. All right, so let's start with domain. Domain is all possible
X by A.
x values. So I'm gonna put an x here. That way we know we're looking at the x-axis. So get your pencil and chop it through the x-axis for me. Anywhere. I don't care where. Everybody, put it on there. So right now, what is my pencil on? What number am I going through on my x? -6. Is that the smallest?
No.
Is -8 the smallest?
No.
But that's the furthest the grid goes. But it keeps going. So I don't have any stopping points this way. What's the smallest x? Close. -infinity. So let's put -infinity because that's the smallest. Now, which symbol do I use to surround it? Am I approaching infinity or am I equaling infinity? So I use a parenthesis using our symbols above. Parenthesis means approach. Okay, so then let's pretend my pin is it goes to negative infinity, right? So now let's go back the opposite way. What's the next biggest x value? I'm going to keep going.
Two.
So why am I stopping at negative 2? That's a stopping point. Why? Because that got removed there. We fell into a hole, right? So that's a stopping point. So I'm going to go from negative infinity to negative 2. Parenthesis or bracket. So you can equal negative 2. Parenthesis. Very good. Okay, but I am not done because you still have a whole other section. So what do I use to separate the sections of domain? What's that called? Union, which means I could be in this domain, or now we need the next section. So from negative 2 to what? What's the next biggest number? Keep going.
Infinity.
So you're saying I go from negative 2 and I go straight to infinity? There's no other breaking points.
Oh no.
Why negative 1, Gloria?
No, ignore me.
Why? You were right. Explain.
Because that's for the vertical thingy.
Uh-huh. And can we equal negative 1 right here? Is this graph going to be on this asymptote?
No.
So that's another stopping point. So we're going to put negative 1 with a parenthesis or a bracket. Okay, we're almost done. We only got one more section left. Union. Now, if I'm going from negative 1, on the right side of negative 1, I'm way up here now, right? Keep going. We're on the opposite section. We're up here now. If I keep going, are there any other breaking points?
No.
So it keeps going to what? So then I'm going to start from negative 1 to infinity. There's your domain. It is long, but they're not always this long. The only reason why it's this long is because you had a hole. Not all graphs have holes. It is weird, but you'll get used to it, I promise. Okay, last one is the range. We're going to do the same exact thing, except we look at the y-axis. So get your pencil. Is this my y value? I'm going through x right now. I need to go through y. So put your pencil this way. You need to chop through the y-axis. So what number am I on right now on the y-axis? Negative 4, right? Okay, that's not the lowest. Is negative 6 the lowest?
No.
Is negative 8 the lowest? I can keep going down. So what's the lowest my range will go?
Negative infinity.
Okay, and as I'm working my way up, look for a stopping point, some discontinuity. If I'm going up and up, follow the trend, follow this path right here. Do I break anywhere?
Negative 2.
There we go. At that y value, negative 2. So, negative 2. Union. Again, starting on the opposite side of negative 2, we came out of that hole. Keep going up. Follow the path. I follow it. I follow it. It's going this way, but is it ever going to touch this?
No.
So what's another breaking point? 2. Close it. Union. I start on the opposite side of 2.
Infinity.
And I go up.
Infinity.
No other breaking points. So yes, it's infinity. Sorry, I ran out of room right there. Okay, question on domain and range.
No.
I hope you were watching there, because if you didn't watch, it's really hard to understand what I just wrote. Huh? What'd you say? Oh. Okay, can I flip it really quick? All right, before I tell you which one I want you to do, I want you guys to look at this first and the second one. Okay, in this first one, do you have a horizontal asymptote? Do you see a horizontal line that the end behaviors are both approaching?
Yeah.
What is it?
3.
3. Good. Now look at this one. Do you see a horizontal asymptote that the end behaviors are both approaching? No, because they're going in opposite directions to completely different numbers. So what would you put for horizontal asymptote here? You put none. You put the word none. Or NA, not applicable. Does this one have vertical asymptotes?
Yeah. No.
Is there a vertical line?
Yeah.
Yeah.
Where?
3. Negative 3. 3.
Everybody agree it's 3?
Oh wait, there's 2.
Oh, there's 2 of them. So you can have more than one vertical asymptote. So you have 2 separate vertical asymptotes here. You see 2 different vertical lines that the graph will not equal. Okay, Does this first one have a hole anywhere? Do you see some bolded open circle point anywhere?
No.
Then you don't have a hole, you put the word none. Does this one have a hole anywhere?
Yes.
Yes. You can see it, you give me that point. Okay, so I want you to pick any of these on here. Pick 2 of them. Work as a group. Do exactly what I did on the front as much as you can. Okay, start with the easiest one you feel. Do what I did on the front.